Hello and welcome to a lesson on order, exponents, and the order of operations with fractions. So all of the things we're going to talk about in this lesson we saw at the end of our module on whole numbers. We're just going to review them again, but this time with fractions. So the first thing we're going to do is we're going to compare fractions. We should be able to look at two fractions and decide which one is larger. Before we do that, let's compare whole numbers. Now if you remember, our whole numbers, we started by looking at them on a number line. So we could create this number line using the equally spaced distances to represent our whole numbers. And on that number line, we can see the order of those numbers, where as we move to the left, we have numbers that get smaller, and as we move to the right, then we have numbers that get bigger or larger. Okay, and we have inequality symbols that we could use to also order numbers. So for example, I could see here that the whole number 4 is bigger than the whole number 1 because 1 is to the left of, it is less than 1. Or I could see that 8 is bigger than 4, or that 4 is less than 8. Again, whatever is on the left is going to be less, and if it's to the right, it's going to be larger, it's going to be more. Okay? So to say those things mathematically, we can use inequality symbols. Inequality symbols would be like this, or like this. So the first one is our greater than symbol. We use that to compare when one number is greater than another. So for example here, we could say that 8 is greater than 4. It is to the right of, it is more than 4. And we can use the other symbol to say that a number is less than another. So we could say that 1 is less than or left of 4. Okay, so we can do the exact same thing with whole numbers and fractions. So fractions are in between the whole numbers on a number line, so I don't have them labeled in here, but for instance, right in between the 4 and the 5, we have 4.5, which is technically 9 halves. Or I could go with 6 1/3 here, right? All of our fractions and mixed numbers that we've been working with in this module, they're on that number line too. They're just hiding in those spaces between our whole numbers. But we can still compare them. And the only way we can accurately compare them is if we're looking at like fractions. We want to be able to compare fractions when they have the same denominator. So if you're comparing like fractions, then this is easy. The like, or the fraction with the larger numerator is going to be the larger fraction. So for instance, if we're comparing 2/5 and 4/5, again, just to kind of review with you, let's say we have these two pictures, and let's say that, oh, maybe I shouldn't use circles. Goodness. Let's make a couple of rectangles here. You don't need to draw this. This is just to make sure you understand here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 2/5, that's this first one here, would be 2 of those little sections shaded in. And then 4/5 would be 1, 2, 3, 4 of those shaded in. And clearly 4/5 is more than 2/5, right? So if we have like fractions, if our denominators are the same, then it's going to be very clear that the one with the larger numerator is going to be the larger fraction. So we're going to say 2/4 is less than 4/5, which means 4/5 is greater than 2/5. In general, if you look at the symbol and the way that it's pointing, that's a gigantic highlighter. The way that the symbol points, it always points to the smaller number. So the inequality symbol points to the smaller number. Points to the smaller number. If I could just write faster, right? Okay, so now if we're looking at the second example, and let me also just, let me go back here. This one is, we're saying here that 2/5 is less than, that's that symbol, 4/5. Okay? Now, if we're looking at the next example, 3/10 and 2/7, it's hard to compare those two because they're parts of different fractions. So we want to be able to compare them as like fractions, which means we're going to want to get common denominators before we try to do anything. So a common denominator for 10 and for 7 is going to be 70. So before doing any comparison here, I'm going to multiply my first fraction by 7/7 and multiply my second by 10/10. So what we're really comparing is 21/70 with 20/70. And I can see from this point, 20/70, I can see now that they are like fractions, that if I had 21 parts of 70, that's going to be more than 20 parts of 70. So 21/70 is greater than 20/70. And again, we're pointing toward the smaller of the numbers. Okay? And let's try that again here. 9/10 and 11/12 are going to be hard to compare here because we're looking at different parts of a different sized whole, and so we want to make like fractions before we do our comparison here. So we need a common denominator for 10 and 12, and remember there are lots of routes we can take for finding a common denominator, but we do have technology that does this for us. I hope I showed this to you, but you can look for your least common multiple for 10 and for 12, and we're looking at 60 for our least common denominator. So if 60 is my least common denominator, although any common denominator will do, so if you were looking at these and thinking, oh, 10 times 12 is 120, you can use that. It would absolutely work. But I'm going to go with the least common denominator here of 60, so I'm going to multiply by 6/6 here, and I'm going to multiply by 5/5 here. So what I'm really comparing is 54/60 with 55/60. And 55 is more than 54, so I'm going to say 54 is less than 55. And again, our symbol is pointing toward that smaller number. Okay? So we should be able to compare fractions in the same way that we compare whole numbers. And yeah, and then we're good there. Okay? Just make sure that they are like fractions so that you have common denominators before you make your comparison. Now, another way you could get around this, again, this is a skill we should have, but we can also use the calculator in case we got common denominators incorrectly. We can verify. If you put 3/10 in and then you put 2/7 in, you can compare the decimal amounts. So I can see 0.3 is bigger than 0.2857. So you can also compare the decimals if you want to put these into Desmos. Okay? Now, we also looked at this concept of exponents, exponential notation. Remember that exponents indicate repeated multiplication, repeated multiplying. So when we did this last with whole numbers, we said something like 6 to the power of 3, or 6 to the third power, or we could even say 6 cubed, meant we were going to take that base of 6 and multiply it by itself 3 times. So the exponent tells us how many times to multiply the base by itself. So it means it's 6 times 6 times 6, which means that thing has a value of 216. Well, that does not change with fractions. Exponents still have the same meaning. We just have repeated multiplication with fractions. So 1/3 to the 4th power, or to the power of 4, means the base of 1/3 is going to be multiplied by itself 4 times. So we have 1/3 as a factor 4 times. So if we multiply 1/3 times 1/3 times 1/3 times 1/3, we multiply straight across the top, and all those ones make a 1. And then on the bottom, we have 3 times 3 times 3 times 3. So 3 times 3 is 9, times another 3 is 27, times another 3 is going to be 81. And so we have 81 in our denominator. And again, you can use your calculator. It will confirm this. So put 1/3 in the parentheses, just like you see it on your paper there, and raise it to the power of 4. Convert it to a fraction, and there it is, 1/81. Okay? Let's try that again. If we have 1/4 squared, 1/4 to the power of 2, or 1/4 to the second power, that means we're going to take the base of 1/4 as a factor twice. So 1/4 times 1/4, and 1 times 1 on the top of the fraction is 1, 4 times 4 on the bottom is 16. So this thing has a value of 1/16. And then 2/5 cubed means the base of 2/5 is going to be multiplied by itself 3 times. It's going to be a factor in there 3 times. So on the top of the fraction, 2 times 2 is 4 times another 2 is 8. And I said 3 times. I meant to put a 5 there. So 2 times 2 is 8 on the top. On the bottom, 5 times 5 is 25 times another 5 is 125. So 8/125. And again, your calculator could be used to confirm all of that. Okay? Now the last little piece, last thing to wrap up our module here is reviewing our order of operations. So we've talked about all the different operations that we could apply to fractions. We know how to add, we know how to subtract, we know how to multiply, we know how to divide, we know how to deal with exponents. So now let's put them all together, right? Maybe not all of them in one problem, but if we do see multiple operations in one problem, remember, we don't want to be taking multiple different paths and end up at multiple different answers. We have that set order of operations to guarantee that we all arrive at the same answers. So remember, our order of operations tell us to simplify anything in our grouping symbols first. So if I have any parentheses, brackets, things like that, fraction bars, square roots, actually I don't think we've talked about, or we have talked about square roots. We want to work on those grouping symbols first, and then we would take care of any exponents, evaluate any exponents. And then we take care of multiplication and division. Multiplication and division, and that's left to right. And so if we have division before multiplication, then we would do that first in the left to right sequence. And then we have addition and subtraction as the last two pieces. And again, addition and subtraction are also happening left to right. And so if there was subtraction before addition going left to right, then we would do that first. Okay? So let's look at our first example. So we have two operations here. We have division and we have multiplication. So those two are lumped together. We're just supposed to work left to right there, which means the first thing we will do in this problem is the division. Okay, so we want to take care of the division. So when we divide fractions, remember, we want to multiply by the reciprocal. So we keep the first fraction the same, we change our division to multiplication, and we want the reciprocal, so we flip that second fraction. And now when we multiply straight across the top, we get 3, and straight across the bottom, we get 10. So we're going to do that division first. And now we can take care of our multiply by 4/5. Made that a little too big. Now we can take care of our multiply by 4/5. And again, multiplication happens straight across the top. So we're going to end up with, and I can see a common factor here. So let's just go ahead and multiply. We get 12 over 5 times 10 is going to be 50. I can see both of these numbers are even. They're divisible by 2. So I'm going to reduce by dividing the top by 2 and dividing the bottom by 2. And so we end up with a final simplified form of 6 in the numerator and 25 in the denominator. And again, this is something that technology can confirm for us, but it's a little tricky with the division symbol, okay? Because remember, Desmos wants to make fractions for us. So let's see, if we took 1/5 and we divided it by 2/3, oof, it looks crazy in there, but we end up with the, what did I do? Type this in weird? Oh, I sure did. Okay, so we have to be careful with that division symbol. So let me make sure I tell Desmos exactly what I want it to do. I want it to take 1/5 and I want that fraction to be divided by the other fraction, which is 2/3. There we go. Now it's typed in there correctly. So then you can see that it gives us that same first result of 3/10. And now I want that 3/10 to then, after that division, to be multiplied by 4/5. And there it is. So that's how it's going to look in Desmos. We want to make sure we tell Desmos to divide first, and it's take the one fraction and divide it by the other. So I don't know if you saw what it did the first time. It actually just divided the 5 that's in that first denominator by 2/3. Just a weird thing. So some of these are hard to confirm with the calculator, unless you have a calculator that has that divide button and actually puts the divide button in there. But in any case, we arrived at our result. Okay, so let's try another one. Here, we want to work, remember, in the grouping symbols first. So the first step would be, let's figure out what's going on inside the parentheses here. So I have to add 8/27 to 2/3. In order to add those, I need a common denominator. And so I'm going to multiply this fraction by 9/9 so that we get that common denominator of 27. So what I'm trying to add here is 8/27 with this becomes 18/27. And 8/27 plus 18/27 is going to make, let's see, 18 plus 8 is going to be 26/27. So let me go this way now. This is a big mess here. I have 2/3 squared, and I want to divide by, in the parentheses now, that sum we're going to call 26/27. Okay? So we took care of the grouping symbols. Next, if we have any exponents, we evaluate those. So now I'm going to evaluate this piece right here. And 2/3 squared means 2/3 has to be multiplied by another 2/3. So 2 times 2 on the top is 4, and 3 times 3 on the bottom is 9. Okay, so let me carry this over again. You can see how some of this gets a little messy. The 2/3 squared becomes 4/9. And so we have 4/9 to divide by 26/27. And so now to divide fractions, we multiply by the reciprocal. So we are going to make this 4/9 times 27/26. And again, I can see some common factors here. So remember, we can make this all one fraction. I could say this is 4 times 27 on the top, and this is 9 times 26 on the bottom, but I can see some common factors. So I can see 9 and 27 are both divisible by 9, so I'm going to divide here by 9 to make 1, and divide here by 9 to make 3. And I can also see the 4 and 26 have a common factor of 2. So I can divide here, 4 divided by 2 is 2, and 26 divided by 2 makes 13. So if we want to use that shortcut of reducing, we're going to make our lives a little easier, right? So from here, on the top, what's left is 2 times 3, which is 6. And on the bottom, it's 1 times 13, which is 13. So 6/13 is our result. And that was a hefty problem there, okay? So we ended up with 6/13. Let's see if we can't get this into the calculator and confirm. So 2/3 squared, and we want that to be divided by that sum on the bottom. So we want to divide it by 8 plus, 8/27 plus 2/3. And fingers crossed, we're going to hit the fraction to decimal button there, and there it is, the same result we ended up with. But you can see that when we put that in the calculator, it doesn't look like what it looks like on paper. Those divisions are tricky. So just make sure you're dividing by that entire sum. That's why that whole thing I have in the bottom of that fraction. Okay? All right. So last one, and I saved the best for last. This is a fun one. We've got two sets of grouping symbols here. So there's these brackets which group all of this together, but then there's these parentheses here. We want to work on the innermost first. So our first step here is to subtract these two fractions. So I have 6/7, and I want to take away 1/3. I need to get common denominators, which is 21. So multiplying by 3 there and 7 there, I can see I'm trying to put together 18/21 minus 7/21. And 18 minus 7 is going to be 11, so we get 11/21 there. All right, so that's that piece. And actually, we can do this as well. Let's try to save a tad bit of work. I know after the grouping symbols, I'm going to take care of those exponents. So 1/4 squared means 1/4 is going to be multiplied by another 1/4. So that's going to give me 1/16. Okay? So what are we looking at right now? Well, we still got the 3 on the outside. We still have the bracket. So it's 3 and then a bracket. The 1/4 squared became 1/16. We didn't do anything with the 3 halves, but inside of the parentheses, we now have 11/21. So now we're here. Now we still have to simplify inside the brackets, and inside the brackets we've got two operations. There's addition, and then the parentheses here imply multiplication. So that multiplication is going to happen first. So we're working on this piece, multiplying these two fractions. So we have 3 times 11 and then 2 times 21. And we've got a common factor here. 3 goes into 3 once, and it goes into 21 7 times. So what we're looking at is 1 times 11, which is 11, and 2 times 7, which is 14 in the bottom. Okay? Let's keep going here. Let's see. We've got now still a 3, still a bracket. Didn't do anything with the 1/16. We just multiplied those two fractions now to make an 11/14. So now I can add. Okay, now I can add. So when I add here, 1/16 and 11/14. I need a common denominator. That's going to be a messy one. Let me go ahead and rely on some technology to help me out. What is the least common multiple for 14 and what was it again? 16. And it's going to tell me 112. Goodness. So what's 112 divided by 14? And what's 112 divided by 16? So multiplying by 7 and by 8. So by, oops, let me change colors. If I multiply by 8 over 8 here, and multiply by 7 over 7 here, then I'm going to end up with, what was it again? 100 and... Oh, I think I multiplied the wrong... Yeah, I mixed these up. Gosh. Sorry, guys. So here, 16 goes in 112 7 times. So I want to multiply by 7 over 7 on this one, and then 8 over 8 on this one. That makes more sense. So that's going to give me 7 over, this is that common denominator of 1/16. And then here, 8 times 11 is 88. And then again, 14 times 8 gets me that common denominator. Oh, it's not 1/16. Oh my gosh. That's 2 mistakes. Strike 3 and I'm out, right? This is 112, sorry. And then 8 times 14 is going to be 112 here as well. And so now, when we add 88 and 7, we get 95 over 112. Whew, we're almost there. So I've got 3, and then in my brackets now is just 95 over 112. And the brackets, just like the parentheses, when there's no symbol in between them, that's multiplication. So the last step here is to multiply 3, which is 3 over 1, times 95 over 112. So we're looking at 3 times 95, 1 times 112. I can see a common factor. 3 is going to go in here once, and then 3 is going to go in here. 30. Geez, I can't divide. Oh, maybe it doesn't go in. My gosh. Nope, sure doesn't. I'm losing it. That's it. Strike 3. I'm out. So I guess I don't need to write it that way. No common factors. I know 95 and 112 won't have a common factor. And since 3 and 112 don't have a common factor, then we could just multiply. So 3 times 95 in the top of the fraction. 3 times 95 in the top of the fraction is going to be 285. And then 1 times 112 in the bottom is going to be 112. I just want to make sure that doesn't reduce and I'm not crazy. I just feel like it should reduce, but maybe not. So let's convert it. Nope, and there it is, 285 over 112. Okay, So that is, again, a monster of a problem. Like, that's so many steps. Order of operations look much worse with those fractions. Work we should be able to do, but again, we have calculators. So let's see if we can't confirm all of this with the calculator. So Desmos doesn't like brackets. If you see brackets, you're just going to use extra parentheses. So let's see, we have a 3, and then I'm going to use a parenthesis. And then I got a second parenthesis. I'm going to put in 1 over 4. And I'm going to close that, square it. And then I'm going to add 3 over 2 next to parentheses, where I have 6 over 7 minus 1 over 3. And then I close that, and then close that, and convert, and boom, there it is. That was definitely much easier to do in Desmos than it was to do by hand. So these are skills we should have, and I would say, like if there's a lot of folks that are out there in the nursing program that are taking this class to go on to the college math class, and this is stuff that's going to show up on that test that you take for nursing school. I can't at the moment remember what it's called, but these are skills we should have, okay? But we do have technology, so rely on it when you need to, or at least use it to confirm your work. All right, so I think that should be enough to get you going on your practice, but as always, let me know if you need any help. Take care.